Review Unit 4B. Some topics to study would be the transformations of sine, cosine, and tangent graphs. Make sure you know all the characteristics, the key attributes, period, amplitude, asymptotes. Make sure you know how to write the equation of a function given a graph. I would look back at our problem situations such as the roller coaster, the Ferris wheel problems, inverse trig functions, angular and linear speed, simplifying expressions using trig identities, solving equations, and law of sines and cosines. Make sure you know those formulas. For the following functions, find the period, amplitude, max, y-value, y-intercept, and determine all transformations from the parent functions. Okay, for your sine and your cosine, and I'm just going to start, first thing, find the period. You have a formula for period, and the formula is 2 pi divided by the b value. Your b value is going to be the coefficient of x, but your x has to be isolated. So right here, this is something typical of on-ramps. You've got to factor out that 4. 4 is the b value. If you don't factor out, you're not going to have the correct transformations. Okay, so if we factor out the 4 from the x minus 4 pi, you're going to be left with 4 outside, and then x minus pi in the parentheses. So our period is 2 pi over 4, or just pi over 2. Okay, number 2, the amplitude. Amplitude is the a value, and that's this guy in front. So my amplitude is equal to 2. It's not negative. It's the distance above and below the sinusoidal axis. Okay, to find the maximum y value, you're going to find, I'll just call that number 3, your midline plus the amplitude. So your midline is your vertical translation. In this example, number 1, we do not have a vertical translation. So my max y value will be 2. My y-intercept, your y-intercept is where x is equal to 0. So where x is equal to 0, and so let's just plug in 0. G of x. So if I plug in 0, and I can plug it into this original function, that's fine, or if I plug it into this, I'm going to get the same value. This is just going to give me negative 4 pi, because 4 times 0 would be 0. So negative 4 pi. Okay, so now let's think about this. Sine is the y value at negative 4 pi. So here's 0, pi by 2, pi 2, oops, how about 3 pi over 2? And 2 pi. If I want to go negative 4 pi, this would be negative 2 pi, negative 4 pi. And so we can see that our y value is going to be 0. And so if our y value, this is all going to be 0. And so g of x is going to be 0. That is going to be your y-intercept. Okay, determine all transformations. Okay, the minus sign in front, that's going to be a reflection. So I'll call that number 5. Reflection over the x-axis. All right, we have a horizontal compression. By 4. That's the b value. And the minus pi in here, we're going to shift this right pi. Okay, let's try number 2. Okay, and the difference you see in number 2 is that now you've got this constant added. So now we have a vertical translation. So if I want to start with number 5, and I'm just talking about it, this is my vertical translation up 2. That means my sinusoidal axis is no longer the x-axis. It is at y equals 2. I have a reflection. This minus sign right here, minus 3, that is going to reflect over the x-axis. or about the x-axis. The 3 is your amplitude, and amplitude, I probably should have written that in the first one, is your vertical stretch. So let me add that to number 1, vertical stretch by 3. This time, how nice, they have the pi factored out. Pi is 3.14, so that is greater than 1. And so this is also a horizontal compress by pi. And then we can see that we are going right 4 units. Sorry, it's a little crowded in there. Okay, so starting with number 1, the period. Period is 2 pi divided by the b value. So my period's 2. Pi's cancel. Number 2, my amplitude. Well, I already said that, so I'm just going to say number 2 is 3. That's the amplitude. That is the distance above and below the sinusoidal axis. My maximum y value. So this function has been shifted up 2. So if I were to just quick graph, there's your x and y axis. This is your sinusoidal axis. This is y equals 2. From this axis, use your amplitude to go above 3 and below 3. Those will give you, sorry, it's not drawn to scale, but this is 3 and this is 3. These will give you your range values. So 2 plus 3 is 5, 2 minus 3 is -1. So this function is going to oscillate between -1 and 5. So your maximum y value is 5. So number 3 is equal to 5. The y-intercept, that's where x is 0. And so let's just plug it in. F of x and 0 minus 4 is -4. So cosine -4 pi. And so this is the x value at -4 pi, which was the same angle in the first problem. And so we know we're looking at like 0. And so the x value at 0 is 1. So 2 minus 3 times 1, 2 minus 3 is -1. So I know that my intercept is going to be at -1. And the y-intercept, that's where x is 0, so there it is. 0, -1. Next, oh, we already did the transformation, so we're done with that one. Okay, number 3, how many periods does tangent have between -pi and pi? Okay, so there's a formula that's similar but different. For tangent and cotangent, the period is pi divided by b, because you will have 2 full periods of tangent in one complete revolution around the unit circle. So the period is half as much as sine and cosine. So my b value is 4. So this is pi over 4. So this is one graph from start to finish along the x-axis. It goes a distance of pi over 4. So if I just want to kind of get an idea, -pi and pi, this total distance is 2 pi. And so the question is, how many pi over 4s divide evenly into 2 pi? Well, that's just some arithmetic. So 2 pi times 4 over pi, those cancel. I'm going to have 8 periods of tangent between -pi and pi. Where's the x-intercept? Okay, so tangent, the parent function, normally does this thing, right? It's right through the origin, and he has vertical asymptotes at -pi over 2 and pi over 2. So what this b value has done is compress it, because normally one period is pi. Now one period is 1/4 of pi. So this one's going to be going between, well, it's half of 1/4. Well, pi over 4 times 1/2, pi over 8. I'm going to have an asymptote at pi over 8. I'm sorry, -pi over 8 and positive pi over 8. Here's my new guy. He's really skinny. And since each period is pi over 4, I'm going to have another intercept. The distance between these intercepts is going to be pi over 4. So where are the x-intercepts for the graph? Well, my first x-intercept is going to be at 0, and then the next intercept is going to be at pi over 4, and every multiple beyond that. And so I can just say pi over 4n. That will give me all the x-intercepts. The asymptotes, I kind of talked about those over here at pi over 8. And again, it's because you take the period, pi over 4, and you cut it in half. So half of pi over 4 is pi over 8. That's how far you are going on either side of the intercept. So pi over 8, and that's going to be, well, I guess if we of this, well, it's not asking for every, I guess we should probably not answer every one, but pi over 8 plus pi over 4n, or if you just want to say negative pi over 8 and positive pi over 8, you can see from the graph hopefully what I'm talking about. If not, please ask. All right, number 6. This one is tangent of the inverse of sine of 2/5. Now, hopefully you recognize that 2/5 is not a number we've seen before. And so it's not on the unit circle. That's what I'm talking about. Inverse sine is going to be defined by quadrants from negative pi over 2 to pi over 2. And please look back in your notes where we talked about this. Inverse sine and tangent are defined in those same quadrants. Inverse cosine is defined from 0 to pi. And again, if you go back and look at your graphs, these have to be functions. So we had to condense or only take a portion of them. We had to restrict the domain on these guys. And so this is what we're talking about. So I'm looking at this guy, and I'm just going to, and remember, this is opposite over hypotenuse. And so if I were to draw my triangle, I'm going to have to draw a triangle. If I were to draw it in the fourth quadrant, then my opposite value would be negative. So I know it's not going to be in the fourth quadrant. I'm going to draw a triangle that's in the first quadrant, and I don't know where, but I know it's going to be a right triangle. And the opposite of this angle, the sine of this angle, is 2 over 5. Okay, and so let's just do a little quick Pythagorean theorem. If I want to find x squared plus 2 squared. So x is going to be the square root of 21. And so that sounds good. I'm going to remove the little x and put square root of 21. And so now what we want to figure out is tangent of this angle. This is the inverse of sine 2 over 5. Now if I want to find the tangent, tangent's opposite over adjacent. And so the opposite from this angle, 2 over root 21. So tangent is going to be, I guess, just 2 over root 21. And I just didn't put a theta. I should probably put a theta. Okay, so let's try number 7. Now this guy we know, pi over 3. Pi over 3 is right here. And let's think about what is your 1/2 square root 3 over 2? I'm doing this all from memory, guys. So if I make a mistake, please just let me know. But the sine is the y value. So I'm looking at this guy here, the y value at pi over 3. And so then I want to find, okay, well, what is the cosine of what angle? Remember, inverse is asking for an angle. What angle has a cosine value of root 3 over 2? And remember, cosine is divided in from 0 to pi. And so from 0 to pi, the only place you're going to have a positive x value is going to be in quadrant 1. So if we think about it, that's going to be pi over 6. Okay, so first thing I see on this is that all of these guys, they're not factored out. So I'm going to have to kind of clean this up. See if I can rule out any. I don't know. They all have the vertical translation. That's this guy right here. That's the D value, or whatever letter they call it. But it's your vertical translation. So we're up 2. And I guess the next thing that we could probably figure out the easiest is the period. Okay, so I can see 2 graphs that we could probably look at. We can look at the one, this upside down cosine graph that starts from 1 and goes to 5. Or we could, do the sine graph. There's also this graph here, sine graph that's going from 0 to 4. Either way, one graph of sine or cosine is 4. So the period is 4. So then let's work backwards to find our b value. So 4 is equal to 2 pi divided by the b. And so if I solve for b, multiply both sides by b and divide by 4, 2 pi over 4, which is pi over 2. So I want a b value to be pi over 2. So see, now we can rule out it's not this guy, it's not this guy, it's got to be one of these 3. All right, so that helps a little bit. Okay, so then the next thing we need to do is we just need to factor out pi over 2 from each of these binomials. So if I divide pi by pi over 2, because in each of these 3 down here, C, D, and E, you've got a pi right here. So let's factor that pi over 2 out. And so we're dividing. And so that's pi, keep change, flip, pi over 1 times, and we're dividing by pi over 2. So flip the denominator, 2 over pi. Okay, so 2, right? And so let's see, I can rewrite this guy as 2 plus 2 sine pi over 2x minus 2. And I can write this guy as 2 minus pi over 2x minus 2. And I can write this one as 2 plus 2 cosine pi over 2x minus 2. Okay, so now we've just got to figure out which one of these is it. And all 3 of these are moving to the right 2. So we're just like, which graph starts here at an x value of 2? Well, hey, we know our graphs, right? If I'm starting at an x value of 2, I'm drawing a sine curve. Oops. This guy right here. And so I need a sine curve. It's not going to be this guy. Now, if this function is going up and down and around, I know it's got to be a positive sign. So my answer's got to be C. That was a good one. Okay, keep moving. Number 9, find the length of A, route to the hundredths. So what I see here is I have I don't have an angle-side relationship. You must have an angle-side relationship to use law of sines. And so since I have an angle between 2 sides, I've got to use law of cosines. And so law of cosines is this guy here, a squared. And I'm going to go ahead and just b and c. Otherwise, I'm going to mess something up. So do this. B squared plus c squared minus 2bc cosine of that angle. And I'm going to stick this in my Desmos, and I'm going to get an answer. And 21 squared plus 32 squared minus 2. All right, I'm going to just give you the answer, but you can put it in Desmos. It's going to be 20.87. Okay, on number 10, this time though, look, we have an angle-side relationship. So I can use, okay, so this was law of cosines. No side angle relationship. This is law of sines when you have a matching pair. So if I want to find little c over sine of c is equal to little b over sine of b. Do a little cross multiply and divide. let's see, by the magic of figuring this stuff out, it's going to be 11.2 or 8, so about 11.3. And yeah, that's all you got to do there. I was going to say, if you're having to solve for the angle, don't forget the inverse. You've got to do inverse to get your angle. Okay, so solve the equation on this interval. Sine 2x, sine x equals cosine x. Okay, so this is one of our double angle identities. And if you look it up, it's going to look something like this. Okay, and then that's times sine x is equal to cosine x. This is just a direct substitution. Look at double angles. Double angle identities. Okay, so if I multiply all of this on the left side, it's going to give me 2 sine squared x cosine x. And if I move the cosine over, now I have a GCF. Both of these terms have a cosine in them. So let's factor that out. Cosine x and now we have a zero product property. So question is, what angle has a cosine value of 0? And if I solve for sine and square root it, sine x is equal to 1 over root 2, or if I rationalize it, hopefully you'll recognize this guy better, sine x is root 2 over 2. So go to your unit circle, find the x value where it equals to 0, and then find your y value where it equals to root 2 over 2. And x is 0 at pi over 2 and 3 pi over 2. The y value is root 2 over 2, and that's going to be at, let's see, pi over 4 and 3 pi over 4. Oh, shucks. One more thing. I almost messed this up. When you take a square root, plus or minus, dang, sorry guys, at least I caught it. 3 pi over 4, 5 pi over 4, and 7 pi over 4. It's all of the fours, because you're going to have a plus or minus. So plus or minus these guys, 7 pi over 4. Sorry about that, but I caught it, so that's good. Number 12, a Ferris wheel is 20 meters in diameter. Okay, first thing I'm going to do is draw a picture. This guy is 20. And it's attached to a platform 2 meters above the ground. So I know that the max height is going to be 22. Okay, because I don't know where I'm going to put my axis here. I guess, you know what, probably I don't want to draw this on here just yet. Okay, here's the ground. Let me start over. And this is 22. And I know this is 2 because it tells you it's 2 meters above the ground. The distance right here is 20. That's the diameter of the Ferris wheel. It says the 6 o'clock position rests on the platform. The wheel completes a revolution in 8 minutes. So from 0 to 8, you're going to have one graph of this guy. And if it's on the ground and the 6 o'clock position, it's going to be right here. You're going to have a y-intercept of 0, 2. If it finishes one cycle in 8, I know I'm going to end up over here. Is that 8 minutes? 8 minutes later, I'm going to be back on the ground. So if you're sitting on this Ferris wheel, and you start here, you're going to be going up and then back down, and then you go back up, and one full circle going up and back down is that 8 minutes. And so it completes one revolution in 8 minutes. The function gives the height in meters above the ground. Find the amplitude. Okay, so we got to like kind of analyze this. And so here's the midline, and it is 10 below the 22, so I know this guy's 12. It's 10 above. There's your amplitude. Amplitude is 10. The average height, that is the midline. It's at 12. The period's 8. That's one cycle. Okay, so now let's find a formula for the height, and whatever, I guess we call it h of t, is equal to the midline. And this cosine curve is reflected, so it's going to be a minus 10 cosine. Now we do need to find the b value, and so our period is 2 pi divided by the b. So if I multiply both sides by b and divide by 8, b is 2 pi over 8, or pi over 4. And there's no horizontal shift, so I'll leave it just like that. We could find a sine function, but for this one, cosine matches very nicely. All right. The only thing, okay, let's just do it real quick. So, if this is 4, that means this guy right here is 2. This intercept right here. So if I wanted to do a sine curve out of this function, same numbers, everything, but if we're doing a sine curve, you're going up and over, it's going to be positive. So you still have the vertical translation, positive because it's going to be going up and over and around. 10 sine, same period, pi over 4, but we're translated to the right 2, so it's going to be x minus 2. So there you go. Number 13, when being burned in a writable CD drive, the diameter of 120 millimeters. This is the angular speed is 120 millimeters of a CD, is often much faster than when playing audio, but the angular speed still varies to keep the linear speed constant where the disc is being written. When writing along the outer edge, the angular speed is about 4,800 revolutions per minute. Find the linear speed. So, this is your diameter, right? So I'm going to need my radius. And that is because the angular speed, or linear speed, is equals to r times omega. And omega, that's your angular speed. That is, let's figure this out, 48 revolutions per minute. That's given. Okay, so we know that the angular speed we want to find linear speed. So let's think about this. Omega is 4,800 revolutions per minute times 2 pi radians per 1 revolution. That's going to give us radians per minute. That is our angular speed. 9,600 pi radians per minute. Okay, so linear speed, I think it was V, is the radius times omega. And that is going to give you a very big number, 576,000 pi, and this is millimeters because our radius is in millimeters per minute. Okay, number 14, an ant is walking around a basketball, has a radius of 5. The ant is walking a circular path that's on a latitude of 60 degrees north of the basketball's equator. Let's save this one to the end. Sorry guys, I'm just trying to get through. It's one of those problems where you had the Earth, and remember we had Austin and somebody living on the equator, and that is this problem. So I'm gonna hold on pause, and maybe we can do that one later. Let's see, this one is just inverse is asking you for the angle. What angle has a y value of 1/2? Well, that's just pi over 6. What angle has a cosine value of negative? Now remember, inverse cosine is only defined for 0 to pi, and so the only angle that this is going to work is 3 pi over 4. Okay, 17, right, both a sine and cosine function. Okay, so I'm totally going to draw a picture for this one because I have no idea. So pi over 6, 2, so let's just put that on our graph. And it says we have a maximum at this value and a minimum at pi over 2. This is going to be pi over 2. And I skipped a space in here because if you think about counting by 6th, 1/6, this guy would be 2/6, this would be 3/6. This is pi over 3. And so that's why I did that. And then -2. Okay, so here's the curve. And so we can see that that is like half a curve. So if I were to draw in a few more, 1, 2, 3, because they have that symmetry, I can see that this would be a nice cosine curve, right? And then it did ask for a sine curve also. So I'll do a different color. Let's do green. If each of the spaces between this are a 6, that means I could have a sine curve that starts here at the origin and would finish right here. Let's see. So that's 3, 6, 4, 6, 5, 6. I didn't draw this very well. It should go like that. So now I just need to come up with the equations for both of those. And so let's just go through and identify all our stuff. So we can see our vertical translation, our up and down is 0. So that's nice. So I'm going to have y is equal to, and then the amplitude, so 2, and then cosine or sine. And then we just need to find the b value. So 1 period of this guy. And so we can count, like if we're just doing the cosine, we start at pi over 6, so that's 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. The period is 5 pi over 6. Okay, so then we have to work backwards to find the b value. So 5 pi over 6 is equal to 2 pi over b. I'll just do a little cross multiply and divide. So this 12 pi is equal to 5 pi b divided by 5 pi. And b is 12 over 5. If I did that right. Just to make sure. Let me just double check. So 1, 6, 2, 6, 3, 6, 4, 6. I went too far. I messed it up. Okay, so this should have been drawn right here at 4, 6. Our period is not 5 pi over 6. Our period should be 4 pi over 6. 2 pi over 3. That'll make our math a little easier. Okay, let me redraw some of this. Sorry about that, guys. So you can see I'm not perfect here. Okay, and so what I recognized is from here to here, that was only 2. I don't know why I counted like 3 more over, but it should have just been 2 more. And so if this is going from 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, yes, it ends at 5 pi over 6, but we started at 1 pi over 6. So 5 pi over 6 minus 1 pi over 6 is 4 pi over 6, which is 1 period. So now let's find our b value. 2 pi, oh, I don't want to write in red, sorry. 2 pi over 3 is equal to 2 pi over b. Well, that makes it easy. B value is equal to 3. Okay. Works out even better. Okay, and so then the horizontal translation for cosine, you're moving right pi over 6, so minus pi over 6. For sine, you're not, it's just 3x. You don't have a horizontal translation. Nice. Okay, 18. This is one of our sum and difference identities, and I don't think you're going to have to memorize this. You will just need to be able to apply it. And so this is like sine of a plus b. And so this is my a value, this is my b value, and the identity is this: sine of a cosine b plus cosine a sine of b. And so then we just make some substitutions. Sine of a, well, that's just sine of x. The cosine at pi over 2, though, the x value at pi over 2 is 0. The cosine of the a value, so it's just cosine x. The y value at pi over 2, that's 1. And so this all cancels. So this is just equal to cosine x. Okay, 19 is using one of our double angle identities. And so it's going to look something like this. And this is just one that you're going to, you should be either given your double angle identities, plug it in, and it looks like this. It's just going to be sine of 2 times 22.5 or sine of 45, which equals root 2 over 2. Guys, look up your double angle identities. Last one. Okay, evaluate cosine 13 pi over 12. Okay, so here's what I'm going to do. I'm going to go ahead and figure out what the heck is 13 pi over 12. 13 pi radians over 12. And if I want to get, I got to look at degrees. See what I'm saying? Like, I don't understand. I don't know what this, I know it's like greater than 180, but if I change it to degrees, then I can easily see this. Okay, so 13 times 180 divided by 12. Sorry, let me just do that real quick. 13 times 180 and divide by 12, 195. Okay, I can work with 195. Sorry, this is going to take, this is 195 degrees. And so I want two angles that add up to 195. Two angles that I'm familiar with. How about, well, if I subtract 150, because 150 is a good angle, and 45. So I can use the sum of cosine of 150 plus 45, and this is your A and this is your B. Using your values on your unit circle and your sum and difference identities, you can work this out. And I believe this identity is cosine 150, cosine 45, minus, and you can work with degrees, minus sine 150, sine 45. And so 150 is over here, and that's negative square root 3 over 2, 1/2. Make some substitutions in, so this is negative square root 3 over 2. This guy, 45, is just square root 2 over 2. The y value, 150, is 1/2, square root 2 over 2. And so this is negative square root 6 over 4 minus square root 2 over 4. There you go.